Hello guys, welcome back to Maths on African Motives. We are still on our mathematics. We are still working on our maths for grade 10. And this is algebraic fractions that we just want to talk about as an introduction, okay, on the simplification of our algebraic fractions. So it can be normal division of fractions. It can be any condition. But here, as you can see, I've got a condition whereby we are simplifying two algebraic two algebraic expressions, one on the numerator, the other one on the denominator, depending on the type of question that you have. All right, so let us see how exactly can we attempt such typical questions. It is of best nature that you are supposed to factorize whenever it is possible when you are given a condition of a division like this. Whenever you're dividing your fractions, it is best that you do factorize, factorize wherever possible. Do factorize wherever possible. All right. So wherever that is possible for you to factorize, please do so. Then you can be able to cancel as long it is between the numerator and denominator. So you can cancel common or same terms. All right, you can be able to cancel common or same terms. They can be terms. You can consider brackets. All right, they can be same terms that you have. They can be same brackets. Okay, you can be able to cancel them as long it is found between the what? Between the numerator and what? The denominator. All right, between the numerator and the denominator. Between the numerator like this, and the denominator. And the denominator. All right, so let us see this. That's the normal part that you just have to consider. There's nothing much there. Okay, there's nothing much. Just like this question, is there anything common that we have that we can be able to factorize? The numerator, yes. X squared minus x, we've got a binomial where x is common. And I told you on the factorization that you have to consider the highest common factor whenever you're just given two terms like this. So the highest common factor is x, the one that is for the smallest exponent, if you still remember. So we factor out that highest common factor, okay, which is x. So if we factor out x, that means we're going to have a bracket. Remember factorization concept. We divide x squared to x. This is going to give us x. Remember, x squared over x. There are two of them. So if you divide by 1, you're going to remain with 1, or you just subtract the exponents. 2 minus 1, which is going to be x to the exponent of 1, which is same as what? Which is same as x. All right, minus, if we divide x and x, remember, guys, we get a 1. We talked about this in our factorization. So this will give us a 1 all over x. So as we can see here, we've got a common term, or the same term x, found in the numerator, and we also have it in the denominator. So these two, they can cancel. So we can cancel out if it is like that. Then we are left with x minus 1 over 1, because this is just going to be a 1. So remember that anything that you divide by 1 is just going to be like that. So 1 over 1 is just like 1. So you've got something like 1 into x minus 1. This is what we have. So if you're saying 1 into x minus 1, 1 times anything, it remains like that. So 1 times x is going to be x. 1 times minus 1 is just going to be minus 1. So the answer there is just going to be x minus 1, okay? Not to write x minus 1 over 1. No. Okay, over 1 does not affect anything. So it just remains as it is. All right, so that was it on this question. Let's try to have or apply the same situation that we have here, that we can be able to factorize whatever that you are given, as long it is possible for you to do so. We've got 4a squared minus 8a, everything over 4a. So make sure that you also watch the video on factorization so that you understand how to factorize these algebraic expression. We talked about this as a separate topic on factorization. All right. So on the numerator, we also have a common term. If you consider 4 and 8, 4 is the highest common factor. Then between a squared and a is the highest common factor, the one that has got the smallest exponent. So let's divide 4a squared divided to 4a, 4 and 4 cancels. A squared and a, we've got the same scenario. This gives us an a if we divide, minus 8 divided by 4, which is a 2. A and a, these two, they do cancel. So it will be just a minus 2, right? Everything over what? Everything over 4a in the denominator. There's nothing that we can do. So as you can see, this one and this one are the same, 4a and 4a. So that means we can be able to cancel the 4a in the numerator and the 4a in the denominator. So this gives us a minus 2 over 1, which is same as what? Which is same as a minus 2. You can even open the bracket, it's fine, or you can just leave it like that. So as you can see, these are just same situations that are happening throughout number 3, number 4. This question 3, just the same. So I want you to try that and see. Let us just try the one with the positive. Number 4, 4m squared plus 4m. So this is question number 4. We are given 4m squared plus m. Is this plus m or what? All right, plus 4m over 4m squared. Okay, plus 4m plus 4m like this over 4m squared. Okay, let's see this one. Let's see this one. Okay, it's one and the same thing that you're going to have. Again, the numerator, as you can see, there's something common. 4 is common throughout, so you're going to factor out 4. M squared and m is common, so you're going to factor out the highest common factor, which is m. The one that has got the smallest exponent, so it's going to be 4m. All right, so let's divide 4m squared divided to 4m. So this is going to give us m. 4 and 4, they cancel. M squared and m, there are 2 of them here. So if we divide by 1m, we're going to be left with 1m, okay? Plus 4m and 4m are the same. So these two, if we divide them, they will cancel each other. We get a 1. All right, so this is over 4m squared. Okay. So let's get back to our situation that, yes, it's true that we can cancel because these terms are outside of the bracket. So they can be able to cancel each other. So you're going to cancel 4 and 4. But let's consider the m. There is 1m. M to the exponent of 1, it means it's only 1. Here there are 2 of them. So if we cancel this 1m into these ones, which are 2 of them, there are 2m times m. We cancel 1. It means we're going to remain with what? With 1m. So as there are 2 of them, if we cancel 1m, we are going to be left with 1m. If there were 3, we cancel 1, we are left with 2. If there were 4, we cancel 1, we are left with 3. That is the scenario. So it means this here can be written as m plus 1 over m. So you're going to have this as m plus 1 all over m, just like that. Okay, you can leave your answer like that. Yes, you can separate m over m plus 1 over m if you want, then you get 1 plus 1 over m, but you can leave it like that as a single fraction because they say as single. Okay, the following single fraction. So you can even just leave it like that as a single fraction. Do not confuse yourself in exam. Just leave your answer at that stage. You are done. Okay, you're done. Do not cancel what does not cancel because we've got an expression and a term. You can only cancel if it was a condition of what that they are the same, like same brackets, same terms. Not to say it's a bracket in another term. No. It can't be like that. Okay, let's see number 5. We've got the same situation, but this one is the division. So we're given this as, all right, so this is question number 5. That's a to the exponent of 3 minus a squared like this over 4, which is being divided to a to the exponent of 2 over 8. Okay, so it follows that, remember, from our division as normal fractions. Forget about algebraic. Forget that you're in algebra. Forget about that. Let's consider normal fractions. How do you simplify on a condition that you've got 1 over 4 divided to 3 over 4? Remember the idea of the division, that you're supposed to remove this division by introducing the multiplication, and you just interchange the second fraction, so it's going to be 4 over 3. So if it is like that I can remove the division and do multiply, I can also do the same under algebraic expressions. So this can give us, before you factorize, okay, before you do that, a to the exponent of 3 minus a squared over 4, introduce your multiplication so that you do not confuse yourself later on. The moment I introduce this multiplication, it means I'm going to just interchange the second fraction. The 8 is going to be written on top, a squared below. So this is going to be 8 over a squared. Then I can now think of my factorization, because now I know that whatever that I can do here can be simplified rather than to work with a division. You end up with confusion there. Okay, I'm going to explain later on. Let us find the highest common factor, because these two can be factorized. We've got a cubed minus a squared. A is common there. But which one is the highest common factor? The one with the smallest exponent, which is a squared. So we are going to factor out a squared. And what do we remain with? A to the exponent of 3 divided by a squared. There are 3 of them. There are 3 a's here. We divide with the 2 of them. With the 2 a's, we're going to remain with 1a. Because there were 3, and we're dividing by 2 a's. A to the exponent of 2 means there are 2 a's, a times a. So it would be a, or just subtract 3 minus 2, because the bases are the same. Subtract your exponents since you're dividing, okay? Minus a squared divided by a squared. A squared and a squared are the same, so this will give us a -1, because they're the same. So we've got a -1. Everything over 4, there's nothing that we can do to 4. There's also nothing that we can do on a. There's also nothing that we can do on a squared. You can't factorize a single term. It's just a single term like that. But it follows that. Be careful here. On this one, be careful. Remember, you can reduce as long it is between the numerator and the denominator. So it does not matter that it is of the numerator of this fraction to the denominator of that fraction. It does not matter. Or it is from the numerator of this fraction to the denominator of this fraction, as long they are common. Like here, I've got a squared on the numerator. I also have a squared in the denominator. I can cancel that. I can do cancel. Okay? The same thing, I've got a 4 in the denominator here. So 4 into 4, that is a 1. 4 into 8, that is a 2. We divide 8 divided by 4, that's a 2. So meaning we can cancel. And this means we are just left with a 1 here. We're just left with a 1. So you're going to multiply 2 times 1, which is a 2, into the bracket of a minus 1. And this in the denominator is just 1 times 1, which is a 1. And like I said, if you multiply by 1, does not matter. Just leave it like that. Yes, you can expand your brackets, which is fine. But like that, you can leave your answer as it is. 2 into a minus 1. You're done. Just like that. This is the simplification. So it needs you to go back to your factorization. If your factorization is not good enough, then please do watch the video of factorization so that you can be able to understand this, because there is no way. We are just going back to all the factorizations. If you check number 6, again, it's another type of factorization that we talked about. This one, x squared minus 4 over x squared minus 2x. Again, we can be able to factorize, remember, from our difference of 2 squares. We talked about this type of equation where these are perfect squares. A squared, or let's just write in terms of x, the one that we are used to, x squared minus y squared. If these are perfect squares, we are going to obtain 2 brackets of x minus y into x plus y, whereby we are simply subtracting and adding the square roots of these terms that we have. So the square root of x squared, which is x. So we're going to have 2 brackets in this case. The square root of x squared, which is x, we've got x here, we've got x here, just like x here and x here. The other one subtracts, the other one is going to add. The square root of this number, which is 4. What is the square root of 4? We know that the square root of 4 is plus or minus 2. So that's why we get a negative and a positive. Okay, it's from that concept of that. But if you consider your formula of difference of 2 squares, again, it's something that is straightforward that you can consider. All right, in the denominator, we've got the same thing that we're going to consider the factorization, but this one is not a difference of 2 squares. Yes, we are supposed to factorize, but this is not a difference of 2 squares. 2 is not a perfect square. X is also not a perfect square. But there is something common, which is x. We've got x squared, we've got x. And what is the highest common factor there? The highest common factor is x, the one with the smallest exponent. So we can factor out this x, all right? So that's x squared divided to x. So x squared divided by x, that's going to be x minus 2x divided by x. This x and this x will cancel each other. So that means you remain with just a -2. So that is just going to be a 2. Already you have written the negative. So like I said, you can cancel as long you have done your factorization, and this is between the numerator and the denominator, whether it's a term or there are brackets which are the same, as long they are the same. Whether you're dealing with a monomial, a single term, a polynomial, a binomial, just a normal binomial or a normal trinomial, as long they are the same. As long they are the same. Just like here, x minus 2, x minus 2, they are the same. So this cancels, we get a 1. So 1 times x plus 2 in the numerator, we get x plus 2. 1 times x in the denominator, we get x. So this is going to be all over x, like that. We are done. Do not force to cancel terms that do not cancel. All right, so that was our question number 6. So you're going to do the same thing. I want you to try as many questions as you can, but let's just try number 6 again. And number 7, it's another type of factorization also that we talked about. So this is question number 7. We are given x squared minus 5x. In some of these questions, you can even check them. They were actually questions that we did as our exactly as they are. Some of these questions, I'm not saying all of them, but I'm just saying some of these questions. All right, anyways, there we are supposed to do the same thing, do factorize. The numerator can be factorized. We're given a trinomial. In this case, we've got 3 terms, and we say this one is an advantage. You're just going to have 2 brackets that you can consider, because the coefficient of x squared here is a 1. All right, remember that. The coefficient of x squared, the first term, is a 1. So you're going to consider that to get a 1, this must be x, and also this must be x. Then what do? You play around with this term, which is the constant. What are the products? 2 numbers that you multiply to get positive 6. Take note, positive 6, product. So we need products, or which are the factors of what? Of 6. But these products, they should give us the middle term, which is -5. If you add them, they must give you a -5. So since this term to be added, the term to be obtained, the number to be obtained is a negative. It means on the products of 6, consider these as negative. Yes, you can have 6 and 1, or 1 and 6, whatever that you want, in no matter way that you want to write it. You can have a 3 and a 2. You can have a 2 and a 3 in whatever way that you want, but these are just the same terms that you are considering, 6 and a 1, or a 1 and 6. But you're supposed now to consider them as negative, since the middle term is carrying a negative. So that means I'm going to put a negative here and a negative. Remember, negative terms, negative gives us what? A positive. So -6, -6, -1, if you multiply them, you get a positive 6. The same thing, a -3 and a -2. If I multiply this, I get a positive 6. Okay, so that's the idea. But if I add these products, if I add them, if I add these two, where am I going to get a -5? So you're going to see that it's here on -3 and -2. If you add these two, you're going to get a -5. Okay, let us just play around with our calculator. Let's see. -3 like this, plus a -2. Just open a bracket and put -2 like this. You're going to get a -5, which is the one that exactly the number that we want here, which is a -5. Okay, let's check -6 and 1. -6 and 1 and -1. This is -1 here, and you're going to have a -6. Let us just cancel this and put -6. Let's see. We are obtaining a -7, not a -5. So these products or factors of 6, they do not work, even though they are products, even though they give us positive 6, but they do not add up to the middle term. So these are the 2 numbers that we want, -3 and what? And -2. So you're going to have a -3 here a minus 2 on the other bracket. The order does not matter. You can start with x minus 2, x minus 3, it's up to you, all right? On the denominator, we've got something, a binomial, 2 terms. So you're just going to factor 2 because 2 is common there. We do not have like x squared, so it's just going to be 2, which is common here. Remember, it's a linear expression that we are talking about, and 2 is common. We've got 2 in 2. We also have 2 in 6. Remember, 6 is same as 2 times 3. So in 6, there is a 2 in 6. So that's why we are saying 2 is the highest common factor. So if I factor out 2, it's going to be 2x divided by 2. What am I going to obtain? 2 and 2, they cancel. I remain with x. All right, I'm going to remain with x minus 6 divided by 2, which is going to give us a 3. So this is going to give us 2 into x minus 3. So as long the brackets are the same, then I can cancel as long it is between the numerator and what? The denominator. And this is exactly what is happening. X minus 3 and x minus 3 are the same. So they can cancel and remain in the numerator. You're going to remain with x minus 2 because this is same as 1 and this is same as 1. So 1 times x minus 2, it is going to be x minus 2 over 2 times 1, which is a 2. So that can be left at that stage as it is, or you can simplify as far as possible, depending with your own simplification, but you're going to see that it's one and the same thing. So I want you to try question number 8, do factorize difference of 2 squares, your normal factorization, do the same thing here. You're going to have the same. All right, let's consider question number 10 together. But I want you to try those questions. If they have got a challenge, try these questions. If you have a challenge on answering these questions, let me know on the comment section so that we can do a video just working on those questions. But for me, I'm just going to work with you guys. Question number 10 is a different type. It's not a quadratic like the one that we are just used. This one that we are just used, just factor out. Okay, let's see. Number 10, we are given to simplify. That's 27 p to the exponent of 3 minus 8 everything over what? Everything over 27 p to the exponent of 2 plus 18p plus 12, like this. All right, okay, let's see. This is what we know. This is what we know. Okay, we've got a cubic expression, which is a difference of 2 cubes, because 27 is a perfect cube. Remember, the cube root of 27 is a 3. 3 to the exponent of 3, it gives us a 27. So it's a perfect cube. 8 is same as 2 to the exponent of 3, which gives us 8. So it's also a perfect cube. So that means there we have got a difference of what? Of 2 cubes. Remember the idea of the difference. The difference. All right. Of 2 cubes. We talked about this type of a factorization that can happen if we have got 2 cubes. All right. Remember, I was considering to say, let's say for the first term and this and that, the last term. Okay. The first term is x to the exponent of 3, and we've got y to the exponent of 3. And you said you're going to have 2 brackets of x minus y into the first term squared plus the product of the first and last plus the last term squared, the last square. Remember our factorization of a difference of 2 cubes. When it is a sum, we're going to add here and here you're going to subtract. That's the difference that you have. Okay. So now that we know this, it means we can write the same 27 to the exponent, 27p to the exponent of 3 minus 8 to the x minus 8 in this way, because we have got 27, like I said, which can be written as 3 to the exponent of 3. And we've got p also being raised to the exponent of 3 minus 2 being raised to the exponent of 3. But remember our exponents again, and if you have given the same exponent like that, it means we are simply having it as 3p like that. Everything to the exponent of 3. That is what it means, because it's the same exponent. So it follows that if I have mn to the exponent of a. This is going to be m to the exponent of a, n to the exponent of a. So it's a reverse that is happening now this way. If you check that way properly. So what it means is that we've got 3p to the exponent of 3 minus 2 to the exponent of 3. Why am I writing this way? I just want us to have it in a normal way, like we just see properly our first term and our last term, which is 2. So this is our first term. This is our last term. So it follows that we are supposed to have this as the first term minus the last. First minus last. So the first term is 3p minus the last, which is 2. So that's 3p minus 2 into the first squared. You're going to square the first term. The first term is 3p. So you're going to square that 3p. So it's like this, 3p squared. That's our first squared. So it's going to be back again to that same exponent thing, where 3 is going to be raised to the exponent of 2, p also raised to the exponent of 2. So 3 to the exponent of 2 is going to be a 9. So this will be 9. P to the exponent of 2 is just p squared. We are raising everything to the exponent of what? Of 2. Okay, that's the first squared. Let's move on to another one. All right. Then we've got the product of the first and last. The product of the first, which is 3p, times the last, which is what? Which is 2. We multiply these two, you're going to get 6p. And it's a plus. So that's plus 6p, as you can see here. Okay. Then the last part is the last squared. The last term, these 2 squared. So it's 2 squared. And what is 2 squared? 2 squared is 4, and that is plus. So it's going to be plus 4. So that's how you use this formula of what? Difference of 2 cubes to factorize for whatever that you want. Once you can do that, it means you'll be able to factorize any difference or a sum of 2 cubes, not difference of 2 squares. No. Difference of 2 cubes. So it means the whole of this part that we see here can be written as this in a factorized manner. So we have factorized. The moment you write this in brackets, we have factorized. So it's going to be 3p minus 2 into 9p squared plus 6p plus a 4, like this. All right, everything over this, but this also can be factorized, as we can see, checking throughout these terms. We have got 27, 18, and 12. There is a highest common term that can be factored between these numbers, which is what? 3. So you can factor the highest common factor, which is 3. 27 divided by 3, which is 9. So this will be 9 p squared. 18 divided by 3, which is a 6. From your calculator, you're going to get 6. All right, but there's a p, so it's going to be 6p. 12 divided by 3, which is a 4. So this is just going to be a plus 4. So as you can see, this cannot be factorized further because we can see it here. It cannot be factorized further. So it means we can be able to cancel because they are the same brackets. 9p squared plus 6p plus 4, and also 9p squared plus 6p plus 4 are the same. So I remain with this bracket over 3. This is what I'm remaining, and they are not the same. So I cannot cancel these two because they are not the same. So therefore, my answer can be written as this bracket on top, which is 3p minus 2. So it's just going to be 3 because we're multiplying by 1. So it's going to be 3p minus 2 over here. We are multiplying by 1. So it's just going to be a 3. So it's just going to be 3p minus 2 over what? Over 3. So this is how these questions can be simplified. This is how we can play around with these typical questions. You just have to be careful. Very, very careful. Your simplification, be very, very careful how you play around with these typical questions of this nature. So it follows that I don't think we've got the same thing, but I want you to try question number 11. Also question number 11, yeah, try that. Question 11, I want you to try this. difference of two squares. Okay, let's do this one together because there's a confusion there. All right, let's do this one together. I'm seeing that you can have a confusion, but let's talk about this so that we avoid this confusion totally. We have to avoid this confusion. On number 11, we are given as 9 minus k squared. Please be very careful on this person. All right, this is what we have. I want you to see in a normal factorization. Okay, do not take this in mind. I'm just showing you what could have happened in a normal consideration. We could have factorized, okay, this is a difference of two squares. 9 is a perfect square. The square root of 9 is a 3. K squared is also a perfect square. So I can just have two brackets, 3 minus k. I say, do not take this in mind. I'm just showing you what could have happened, which is wrong. In fact, which can affect you in your simplification. Not to say it's wrong, but I want you to see. And here I've got k and k. You take your k, which is highest common factor, you factor it, gonna be k squared divided by k, which is k, minus 3k and k, which is gonna be like this. Then you go to a situation where you wonder to say, how can I now, because these two are not the same. This is 3 minus k. This is k minus 3. They are different. They are not the same. They are very, very different. Why? K here is carrying a negative. Here it's carrying a positive. So they're different. 3 is carrying a positive here. Here it's carrying a negative. So they're different at all. All right? They're different. K, 3 minus k is equal to minus k plus 3. If it was that way, that the minus k is still the same. The 3 is still the same positive, but there is different. So you're supposed to factor out this and that. So if there are two brackets, most of you have a confusion to factor out. That's why I'm saying avoid that. Otherwise, you could have obtained the answer. I'm going to talk about after this one so that you do not have a confusion when simplifying this one. Okay, so this is what you do. Always, always, always take this in mind. Always. If you are given algebraic expressions, and there is the one with the highest exponent, which is like this one, k squared, and also here there's k squared. Always start with those highest, with the terms with the highest exponents. Always start by those. That's the first thing. Secondly, make sure that you work with that as a positive. We shall see this happening in our addition and division. That's why I'm saying let's avoid it now, because in addition and subtraction, those terms, they will be there tempting you to add or to add them as brackets, while they are not supposed to be part of brackets. Why? Because they are not starting with k squared, and also they are not a positive. So let's have this. So it means 9 minus k squared can be written as, these two, they are equal. If I write this way, is equal to, I start with minus k squared like this, then plus 9. Here, guys, I haven't changed anything. I haven't. I just started to write with the highest exponent, which is 2, but they are the same because this is minus k, this is still a minus. Okay, this is positive 9, this is positive 9. So I haven't changed anything. But if now I write this as a positive k and this as a negative 9, I have changed. I have changed. It's now wrong. Okay? But still, I did that. But still, the k here is a negative. How can I make it to be a positive? I have to factor out that negative, which is affecting k squared. So if I factor out this negative affecting k squared, it means I'm going to have negative divided to a negative. Negative gives us what? A positive. Now our k is a positive. But it does not end at k. No. It has also to go through the other term. 9 divided by a negative. So it's a positive versus a negative. Positive and negative, it gives us a negative. So it will be minus 9. So it means, guys, the 9 minus k squared that we are seeing here can be written this way. Please do not confuse yourself, please. I just want to start with the k squared and also to have it as a positive, not as a negative. So I want you to see now, if you have this, the advantage now, let's take this. So it means we're going to have this as, all right, we're going to have this as this one, the 9, we said all this part is equal to this. So I'm going to take this as it is minus, all right? So this is going to be minus into k squared minus 9, like this. Everything over k squared minus 3k. So here I was just rewriting my expression so that it can follow suit the other one. Once it's in that manner, it's now easier for me to simplify. Not to saying the first way that I talked about was wrong. No, it's not. It's not even wrong. No, 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 no. But most of us, we have a tendency of making more mistakes there. That's why I say, I let me avoid that. All right. So here we are back. Our difference of two squares, we can see it. 9 is a perfect square. K squared is a perfect square. So you're going to have two brackets that we are going to factor out. But the negative is already there. The negative is already there. So it's going to be the square root of k squared, which is k here, another k here, the square root of a 9, which is a 3. So you're going to have a minus 3 and a plus 3, or a plus 3 and a minus 3, depending on the way that you want to have it. Then in the denominator, we've got a common term between k squared and 3k, which is k. K is the highest common factor. So k squared divided by k, there is 1 which is going to be left, minus 3k divided by k. K and k cancels, will remain with what? A negative 3. So that will be a negative 3. So now I want you to see this. You can see that k minus 3 are the same. That negative that I was talking about in that previous method is that one that you are having there. Already it's there, and already you are canceling the correct thing, because in that person you have, okay, let me finish this one. I've got I'm gonna confuse you. Let me write this way. So you're gonna have minus on top because this canceled and you got a 1 and a 1. So this is gonna be minus into k plus 3, minus into k plus 3, like this, over k. So you can leave it like that, or you can even expand by the minus throughout, which is fine. Okay, I wanted to say, if you do the first method the way that I talked about, to say this can be simplified this way, you are going to see that you are going to obtain the difference of two squares, 9 minus k squared, which is going to be 3, minus k in one bracket, another bracket, 3 plus k, as I explained before. This one, as we saw, that you're going to have two brackets from k into k squared, which is k squared divided by k, which is k, minus 3k divided by k, which is a minus 3. Most of you now, you have a tendency to think that these two are the same. You don't recognize that when it's under that exam pressure. So you simply cancel out, these two are the same, I cancel out. This is now wrong. You are now obtaining a wrong answer, 3 plus k over k, and this, they are different. This one is same as minus k minus 3. So how do you correct yourself when you have already factorized this way? Okay, you consider these two brackets to say, all right, these two brackets, they are not the same. Yes, they are not. 3 minus k and k minus 3. Yes, they are not the same. But there's something familiar there that I can play around with to make these two brackets to be the same. What is it? The negative. If I can just factor out this negative out, okay, negative, I remain with a positive k. A positive k like this, all right? Then the 3 divided by a negative, it gives us a negative 3. Okay, then this one is not, it's not affected. It's not the one that I'm focusing on. No. So I just have to write as it is, 3 plus k. All right, everything over what? The bracket here, k into k minus 3. So now I can be able to cancel, they are the same, these ones. All right, so that means at the end, I'm gonna obtain minus into the bracket of 3 plus k over k. These ones, they are the same. These ones, they are the same. They are not different, they are the same. So it means we could have avoided that by doing this. or we could have avoided it through this way. So I don't know which one is easier for you, but I think the first one is easier because it's not a tempting one. The second one is tempting because most of you want to see this, you cancel this and say they are the same. This is what most of you are doing. So that's why I'm saying it's a tempting one. It's a very, very tempting one. The first one is better off because we have already simplified it. It's a better off thing because already you are done. You just consider, say, all right, as long here I'm not having k squared and k squared, I have to write it that way. So if it is x squared plus, let's say I've got x squared minus 1 over the other one, it's 1 minus 2x plus x squared. I have to rewrite in a way that I understand. This is going to be x squared minus 1 over this. I'm going to start with the x squared, the same x squared that I see here. So this will be x squared minus 2x, and now follow the order of my quadratic equation and so forth. I'm going to factorize. I've got a difference of 2 squares, x squared minus 1. 1, remember, it's a perfect square, is same as 1 to the exponent of 1. So that means there I'm going to have 2 brackets x and x here, the square root of 1, which is 1. So I'm going to have minus 1 plus 1 over. I do factorize again these 2 brackets. I've got x and x. Remember, the coefficient of x squared is a 1. So I'm going to have x and x in these 2 brackets because here there is a 1. So if that is a 1, all right, if that is a 1, this one, that means you're just going to have x and x. Then I consider now the products of 1 or 2 terms that I have to multiply to get a positive 1. Add those numbers, I get a negative 2. Do I have such numbers that I can multiply to get a negative 1? By add, I get a negative 2. That's a negative 1 and a negative 1. If we multiply this, we get a positive 1. But if we add, we get a negative 2. So you're going to have negative 1, negative 1. There is a straightforward thing. I can cancel x minus 1 here, right? Yes, there are 2 of them, but 1 is being canceled. So another 1 is going to remain, okay? You canceled 1, not 2 of them, okay? If there was another one, then you, but here there was just 1 that you canceled. So this at the end is just going to be x plus 1 on top, because remember I said this is the same as a 1. So 1 times anything, it just remains as it is. So it's going to be x plus 1 over 1 times x minus 1, which is just going to remain as what? As x minus 1. So I have this in simplest form. I have simplified this to the last extent, and there's nothing that I can do. Never be tempted to cancel x and x. This is just an expression different to another expression. So never be tempted to cancel. So this is the idea that I'm just gonna, just wanted you to see that it can be that you just write in terms of the positive. If you understand that, it becomes easier even to approach any question. Even your addition, you see that in addition and subtraction. All right, I'm not gonna focus on other questions. I'm just gonna focus, all right, it is something here. So let me just focus on number 313. Because it's the same thing that they want you to see here. This is 10 minus 2x. So once you understand this idea, guys, you see this, it's happening throughout. There are so many questions of this nature. Figure out first. All right. I have got an algebraic term. Yes, I've got an algebraic term. Negative 2x, you have got x. Let me start with x, the same x that, because I'm used to that. I'm used to x plus 3, x, no, not something like 3 minus x. We are not used to that. So let's avoid that very, very much. So how am I going to avoid that? All right, so this is just going to be, I'm going to start with write negative 2x. So this will be negative 2x plus 10. It's like that. It's not an equation where I have transposed one term to another where something changes the sign. No. We are just rearranging our terms so that we have got x, but still the x that we have in the numerator, yes, it's an x, but it's a negative. So you have to consider that. How can we make this to be a positive? We have to factor out the negative, all right? So it's a linear expression that we have. So we are going to factor out negative 2. So that negative 2 to negative, it becomes a positive x. Negative, positive, all right? A positive and a negative, it gives us a negative. So that's 10 divided by 2, which is going to be 5, but having what? A negative. Everything over x minus 5. There's nothing that you can do unless maybe if you just want to factor out a 1 and write it as x minus what? as x minus 5. It's one and the same thing, just one and the same thing. So this can cancel out. You remain with minus 2 over 1, which is going to be what? Which is going to be equivalent to minus 2. So you see, how do these questions come? They just want to play around your mind. They are very, very busy with that each and every day. They want your mind to be very, very sharp. So that is, they are busy with that. So they want you to see, they want to test you, sharpen your mind, all right? So they just try to sharpen your mind as much as they can. All right, let us see number 15, which is also the same scenario that we have. We've got a 3 minus x to the exponent of 2 like this, over x squared minus a 9. So you'll be tempted because this is a negative x, and even and the way that we are seeing it, we are starting with a positive, we are starting with a 3. So how can we avoid that? Even inside a bracket that is being raised to the exponent of 2, it can be done. It can be done. How? Okay. If we were to rearrange this, guys, if we were to rearrange this, it was going to be like this. It was going to be minus x plus 3 like this to the exponent of, remember the exponent is there, okay? Okay, let's move stage by stage. The exponent is still there, but I want my x to be positive, just like positive here. So how so? I'm supposed to factor out the negative. But there's a square already. So it means I'm factoring out this bracket being affected by a square. So as I factor out, I'm supposed to consider the square also. I'm supposed to consider that. So it's going to be minus 1 that I factor, the negative that I factor out, so that this can be a positive. I just want this to be a positive, but having in mind that there's a square. So it's going to be minus the negative x divided by negative. It's now a positive x. Positive and negative, it's now a negative 3. But considering the square that we have before this one should be considered. And if you consider that, it follows that this is just the same as we are raising a negative to the exponent of 2. And I told you guys, a negative, when raised to an even exponent, it becomes positive. So a negative 1 to the exponent of 2, it becomes a positive. So this becomes a positive. So we just left with a bracket of x minus 3 squared. The negative vanished already. It disappeared. Not just it disappeared, it was raised to an exponent of what? Of an even number. So it becomes what? A positive. So instead of writing a positive, just leave like that, okay? All right, over. Now we focus on x squared minus 9. What is it that we have? A difference of 2 squares where we can factor out, where we can determine the square roots. The square root of x squared, when I have 2 brackets, remember x here and x here. So the square root of x squared, which is x, the square root of 9, which is 3. So you're going to have negative 3 here and a positive 3. Remember our idea of difference of 2 squares. So here there's a bracket of x minus 3, also a bracket of x, but there are 2 of them. So you're supposed to cancel 2 brackets. But this is the same way, guys, as writing as there are 2 brackets, x minus 3. I want you to see into another bracket, x minus 3 squared, means there are 2 brackets. Everything over like this. We've got x minus 3 in the denominator and x plus 3. This is what we have in the denominator. So this can be simplified as we can see that here we can be able to simplify the x minus 3 can cancel with this x minus 3. All right, there is another one remaining. So which one is it going to cancel? There's nothing that it can cancel. We do not have any other x minus 3. It was just 1 in the denominator and we used it. So we are left with nothing. So it means it is just going to remain as it is on top, as the x minus 3 over the x plus 3, like that. So that is how we could have simplified this type of a question. As you can see, that was it. So I just want you guys to go through the questions. Like I said, Here we cannot divide this, they're just done. So I want you to go through these questions that I left out. Let's try to revise as much questions as we can on these revisions. There are so many things that we need to learn from our normal factorization. Revise also your factorization as a topic. Factorization as a separate topic on its own, as a subtopic on its own. From linear, quadratic, which are the trinomials, from the grouping of terms, all those basics of your factorization, difference of two squares, the difference of two cubes, the sum of two cubes, everything has to be done. So make sure that you go through the videos. Like I said, check the playlist. So you check the playlist for mathematics grade 10 on this YouTube channel. You're going to see that we've talked about this factorization, or just check the playlist under the algebraic expressions. All right, under the algebraic expressions, everything that you need to know about the algebraic expressions in your syllabus is there. So make sure that you watch those videos, revise, also with question papers, so that you see how do they ask on this particular section. Like I said, we're going to talk about what? Addition and division, addition and subtraction in our next class. So make sure that you understand these basics first.